Let's do some practice. I'm going to move pretty quick, so pause and rewind as you need. Number 2, are these congruent? I see that the angle we have matches up. Now, when the lines are parallel like this, that means that if one angle matches up, they're all going to match up. So no need to check the other angles. Now, we do need to check proportionality of the sides. So from my 105-degree angle down here, the longer side is 6, the shorter side is 5. Up here, longer is 30, shorter is 15. So let's compare corresponding sides. So long side on the top compared to long side on the bottom gives me a ratio of 5. Short side on the top compared to short side on the bottom gives me a ratio of 3. Those are not the same, so no, these two shapes are not similar. They're not the same shape at all. Over here now to the next, let's do an angle check. Okay, I got angles matching up, no problem. Now let's check sides. So comparing on the bottom shape, the biggest side, to the top shape, the biggest side, 28 divided by 21 gives me a ratio of 4/3, so 1.3 repeating. Now let's do the same thing with the middle sides. So bottom shape compared to top shape, and see what we get. 15.2 divided by 11.4. Oh, hey, matches up. So far, so good. We got to check them all. And then lastly, this top base on the bottom, top base on the top, 16 divided by 12, matches up again. We got to get the exact same result each time, and yes, these are similar to each other. Let's keep going. This is the same idea, except you notice the shape has been tilted, but the process is the same. Check the angles. 1, 1, 1, 1, 2, 2, 2, 2. Angles match up. So let's do the bottom base here on the big, bottom base here on the small. That's a ratio of 3. The kind of sides of the trapezoid here on the big, the sides of the trapezoid here on the small. And let's see what we got. 8.9 divided by 2.2. Ooh, no, that is something else. Now, at this point, you can stop. If they don't match, they don't match. But just for practice, let's also check the other side. So 10/6, 10/6. It's a different number again. So if any one of your comparisons doesn't match, that's all that matters. No, these are not similar to each other. Over here, let's do it one more time. Check the angles. 1, 1, 1, 1, 2, 2, 2, 2. So a lot of isosceles trapezoids in these even numbered problems. Let's compare longest side to longest side. That's a ratio of 6. Let's compare kind of diagonalish side to diagonalish side. So 27 divided by 4.5. That's also 6. So far, so good. And then let's check the little top bit compared to the little bottom bit. Those are the double angle side, that's 6 again. Okay, we've got the same number each time, so these shapes are similar. For this next set, we know that the figures are proportional. We're supposed to find the length of a missing side. The important part is setting up your ratio, your proportion, fraction equals fraction, correctly. So find sides that correspond. Looking at the shapes, this number on the bottom and this number on the bottom are corresponding sides. The one I don't know corresponds with this one that I don't know. So it's kind of like bottom, bottom, top, top. When you now set up your fraction, I always like to start with the question mark and compare it with its corresponding side. That's going to be the same ratio as the 32 compared to the 40. Now, when you're setting up your fractions, be consistent. I went little shape on the top with the question mark. So when I do my second fraction, start with the little shape, the 32, on the top again. Now cross multiply. 40 times the question mark equals 20 times 32, which is 640. Divide by the 40, divide by the 40, and that question mark should end up being a 16. Check and see if that's reasonable. So in this shape, I notice the top is half of the bottom. Over here, half of 32 would give us that 16. It looks good. Over here now, Same thing, let's match up some corresponding sides. So just looking at the shapes, the 3 and the 9 kind of match up, and the question mark matches up with the 15. So let's set up our ratio. Question mark compared to 15, so small shape to big shape, is the same as 3 compared to 9. Cross multiply, 9 times the question mark is 45. Divide by the 9, and we're left with question mark is 5. Does that seem reasonable? Well, it should be a smaller number than 15 since it's from the small shape. And yeah, I think if this is 3, that looks like it could be 5. Seems reasonable to me. Now, when the shape is maybe tilted a bit, you do the same thing. You just have to be very careful about lining things up. For example, this 12 looks to me like it kind of matches up with this 4. So it's this side part to this side part. The question mark looks to be the shorter of the two parallel sides. So that's going to line up with 6. Let's set up our ratio. Question mark compared to 6 is the same as 12 compared to 4. So question mark is on the top. That means 12's got to be on the top in the second fraction. Cross multiply. 6 times 12 is, that's 72, right? Yeah, okay. So 72 is equal to 4 times question mark. Divide by the 4. And 72 divided by 4 is 18. So that question mark number that we're after is 18. Does that seem reasonable? I'm going to say it does. It's certainly bigger than what we started with. And if that's 12, I can buy that that's 16. Let's go again. In this particular rectangle, I don't know the question mark. It looks like that corresponds with the 7. And then the 10 and the 5 look as though they relate to each other as well. So let's set up our ratio. Question mark compared to 7 is going to be the same as 10 compared to 5. So cross multiply. 5 times question mark equals 70. Do that division by 5, and 70 divided by 5 is going to give me that 14. Okay. Does that seem reasonable? Well, this one's a little easier to kind of see in your head, right? The small number doubled is what gives me the big number. And so 7 doubled gives me that 14. We're in good shape.